Alright, so this is an example of a series containing 82 terms with the following as its first four terms, and we're supposed to find the sum. So the first thing we're going to do is we're going to make a list of what we know.
What
So
are
we know
you doing?
we're doing math. So okay, here we go. So our first term has a value of 542. Now let's look at this and make sure that it's arithmetic.
5 and 4.
It looks like we're going down by 12 here. We're going down by 12 here, and we're going down by 12 here. Hence, this is a decreasing arithmetic sequence or series. So D is negative 12. Okay, we know that this series contains 82 terms, so N equals 82. So I'm going to go ahead and I'm actually going to find the last term first. Okay?
I can't do
Just
that.
okay.
Okay,
Can you guys stop talking? Okay. Can you go see Daddy? Okay, go see Daddy. Kev? Okay, so we're going to say 542 plus negative 12 times, we have 82 terms, N, which is 82 minus 1.
And
Okay, Kev equals 542 minus 12 times 81. Okay, so we are going to go ahead and put this into our calculator, and we find that our last term has a value of negative 430. Okay. Alright, now if I wanted to just go ahead and use the summation equation that has the built-in value so I don't have to find out, that's fine. I'm just showing you another way to do this besides the last example we just did. So, now I'm going to go ahead and find the sum of our 82 terms. So, it's half times the number of terms, which is 82, times our first term, plus our last term. So the sum of our first term and our last term gets multiplied. Okay, so when I go ahead and put this into our calculator, we get a value of 4,592. Okay, we have one more example and then we're going to be done for today. So again, you don't have to find the last term first and then plug it in here. You could do it like we did the prior problem, where we use this equation where we only need the common difference, not the last term. Okay, so our final example of the day says a sequence has a common difference of negative 28, 31 terms, and the last term has a value of negative 812. So I'm going to go ahead and set this up and say D equals negative 28, N equals 31, and L equals negative 812. So clearly what we're missing, we can find four things with that last term equation. We're missing the first term. So when it says that find the value of the first term, that's not a huge surprise since that wasn't given. And then we're going to find the sum of this series. So we do have to do this problem in two parts. So we're going to say this, L equals A plus D times quantity n minus 1. So in this case, L is negative 812. We don't know A, so we're going to leave A as A. D is negative 28 times 31 minus 1. So this ends up being, okay, so negative 812 equals A minus 840. Okay, I'm going to add 840 to both sides. Okay, 840 to both sides. So 28 equals A. Okay, so that's the first term. So, sorry, we have a couple of kids here today. So, A equals 28. So now we have everything we need to find the sum of this series. So we're going to say the sum of our 31 terms equals half times our number of terms times the sum of our first term, which we found out was 28, plus our last term. Okay, so we could go ahead and simplify this or put it straight away into our calculator just like we see it on the screen. And we're going to end up with negative 12,152. What this tells me, okay, is that most of our terms are negative. Anytime you get a negative sum, you have to have negative terms, otherwise your sum wouldn't be negative. And more negative terms well, you have to have the sum of your negative terms have to exceed the value of your positive terms. All right, so let's just go through and make sure that we hit all of the learning targets. So hopefully you can at this point describe what an arithmetic sequence or an arithmetic progression is. Okay, and then you can compare that to an arithmetic series. So what makes an arithmetic sequence different than an arithmetic series? Okay, can you find the sum of a series? We did that 4 times in 4 different examples, so you should be set on that one. Can you find the value of the last term or the first term? Well, we just found the value of the first term, and then we found the values of last terms in a couple of examples. So that is all for lesson 8C1. Make sure that you bring your notes to class with you. Thanks. Bye-bye.